Hi everyone. So today I'm going to talk about how do you write automated tests for your Flutter apps. So before we start, let me introduce myself. Uh, so my name is Yong Shean. I am a web and mobile app developer. Actually now just more focused on mobile app. I'm developing Android and iOS app using Flutter for my company, Comerge. And yeah, if you want to get connected with me, then you can follow me on Twitter or LinkedIn. I also write some blog articles on Medium. So yeah, let's get started. So perhaps I don't have to convince you at this point, like why should you write tests? Because that's part of the essence of software development, where the purpose of tests is to verify if your app works as expected. So we will want to automate the test as much as possible so that when we want to deliver or ship our app, it can be faster and you don't have to worry too much about whether your changes or your bug fixes, it actually breaks some other parts of the app. So generally there are 4 different types of testing. If you are not new to software testing, then probably you have seen this before. So I adopt this diagram from the testing pyramid that was created by Kent C. Dots from the React world. So if you guys have heard about him, then probably it's not new for you. So there are 4 different types of tests here. So the first part is static analysis, which helps to do the type checking. So as you might have known that Dart is a type language, unlike some other languages that you might have come across before, like JavaScript or Python. They are more dynamic, but for Dart, you have to define all the types in your code. So at least at this part, if you want to make sure that your type matches, then it's already been done by Dart itself. Then going up one level up, which is the unit testing and also the widget test. So unit test is just testing your functions or each of your methods if it's working as expected. Then after that, you have the widget test, because in Flutter, you are using widgets. So even your app itself is a widget that contains of many child widgets. Like I think I can show you later. And finally, we have the integration testing. This one in the world outside of Flutter, I think most people will regard this as the end-to-end test, where you have to fire up an instance. If let's say you are testing on browser, on web, then you are firing up a browser to run the test. Then for mobile apps, then you are actually firing up an Android or iOS emulator to run the integration test. So here I show you the development or testing cycle. So at which point you should write tests and at which point you should implement the function. So it depends on you or the team. See whether if you want to opt for test-driven development, so it's the TDD, then you will start to write tests first. Or else, if you're like me, then I actually prefer to implement the function first. Then after that, I write the test for that function. Then after you have written the test, then you should run the test once and see if the test failed. If it fails, then you can check, okay, if your test is written correctly, then you can go back to your function implementation and change some of the code and run your test again. So you repeat the cycle until you got your test pass. Then after that, yeah, you can take a break and then continue to write the next function or the next test. So first of all, let's talk about the unit test. So what is a unit test? A unit test, it tests a single function, method, or class where the goal is to verify if the function is correct under a variety of conditions. So in this test, if there is any external dependencies, they should be mocked out. So unit tests, they are limited to things. So they don't do like they don't do this IO. They don't read or write to this. They also are not in charge of rendering to screen, nor they are testing whether the function can receive a user actions from outside the process or not. So let's look at one of the example function. So this is one of the implementation that I've written. This is a validation function. So for example, if you have a text field that takes in some values, so before user submit the form, then you want to make sure that, okay, at least there is a value in this mandatory field. So I can put in this is required validator in my form. So what these functions do is it will take in a string value, and then it will check if the value is empty, then it should return an error message called required, else it will just return now. So yep, when you are writing the test, then you should ask yourself a few questions. So for me, I will ask like, okay, if I did not provide anything to the function, will it return me required? And then the second question, I will say, okay, if I did provide something, a value to the function, will it return me now? Now means there is no error message or anything is returned. Okay. So this is how your test would look like. So the group is something that helps you to group similar tests together. It is not something that you need to put every time, but when you have a lot of tests, then it can help to organize your tests correctly. Then you can write your test description here. And then inside you have the expect statement that checks that, okay, if my function is required, and then I put in the input that is empty, then it should return me this string. Then the second test, which is if the input is not empty, then it should return me now. So I just I use the function here, and then I put something like a letter A, then I should expect that the output is now. So far, I think it looks pretty straightforward for unit tests, because we should only let a function to do one thing. So that's the single responsibility principle. So when you are writing tests, it actually helps you to limit what a function can do. So next, I will show you an example when we have external dependencies. How should we mock the dependencies out? For example, if you have this function that depends on some remote data here, for example, I have the supplier service, and then I have a function that fetch something. So what is this fetching? It is fetching a post from the supplier API. So you can imagine that the implementation of this is a HTTP GET call that return me a JSON of a list of posts, probably. And then, yeah, I can put them into a list of supplier object if I like. So what happens if we test this directly? Actually, if your API, if your fetch method, it doesn't require you, for example, an authentication header, you probably still can run the test correctly. But then if you are building an app where, okay, if you call this API, you need to log in first, you need to get some token to authenticate your request, then you will face issue when you are running the test. So what do is we need to create a mock of this API. So we can use Mockito to help us to create a mock version of the supplier API. So once we have created, then we can pass it in to our original supplier service. So like here, I will need to add some one extra argument to here, so it can take in the API client, then I can use it here. So after that, then you can continue your test as usual. So the good thing about using Mockito is you can define what is the expected response from your mock function. For example, just now I have created the mock supplier API, which is extended from the mock class from Mockito. Then here I can use the when, then answer. So when is when you call this function, then it should return a list of supplier. So you can define what is the expected response that you want from your function. So in this way, you can define a few scenarios. For example, if you have an empty list, so you can define, okay, for this test, I want to test if my function can handle empty list correctly. Then I have the second scenario, which is it return me a list of one supplier object. So here you can define like, okay, when supplier API.fetch suppliers, then it should return me this list of supplier, which I've just defined here. Then after that, you write your test. Okay, the testing is actually your supplier service. So when it fetch all, then I should expect that the result should contain a length of 0. And then the second test is, okay, I should expect this result should contain this supplier object. All right, then after that, we have widget test. But I think before we go into that, I can show you in the code, how should the unit test look like? So for example, here I have the fetch post button I created. Then when I click on this, then actually it is printing out the result that I fetched from the post service. Let's look at here. Yep. So I have a flat button that with the label fetch post, which is this one. So when I press it, it should call my post service and fetch all. So let's take a look at our post service. So in the post service here, here I have the API provider. So I define this so that in my test, I can put in my mock API provider. So if it's not in the test environment, then it should just take the default API provider. So I have the fetch all function defined here. So I'm calling on the fetch post method from my API provider. And then I just print out the result, which is what you see in the console. So API provider is nothing special. It's just a HTTP GET call, and then I put it, I decode the JSON and then put it into a post model object. Okay, then how about the test? So the test should look like this. When the fetch all is called, it should return a post model object. So here I can use the when, then answer here I just put in the mock API provider, which I create here. So it extends the mock object from Mockito. Then after that, okay, I want it to return me a post model with title and body. So when I run this, I will just say, okay, I want to make sure that the result is a type of post model. So let's run this. Then you should be able to see it here. Yep. So green tick, pass. And then it prints out that, okay, the title is actually this title. Okay, let's go back to the deck. So next I will talk about the widget test. What is a widget test? So the widget test, the goal is to verify a single widget if the UI looks and interacts as expected. So it can involve multiple classes, or it can involve multiple child widgets if you have many child widgets under that widget. And also it requires a test environment that provides the lifecycle context for that widget. So what widget test can do, it actually can do everything that unit test can do, and it is responsible to render the layout and instantiate the child widgets. You can also test whether it can receive and respond to user actions and events correctly. So for example, if you have this widget, I think you probably have seen this before. If you have used the Flutter create command to create a new Flutter project, then yeah. So this is the code. And then when you want to write the test, just like when we are writing unit tests, you should ask yourself a few questions as if you are testing it manually. So the first question I would ask is, will it display all the info that I'm expecting to see on the widget? And then I will ask also, okay, if I tap the button, will it show me the new number? So how will you write the test? First, you have to pump the widget. So my app is actually the root widget that contains this my homepage widget. You can also only pump the my homepage widget if you want. So it depends on you what is the context of the widget you want to test. So first you can check the initial state. Okay, at least I want when the widget is rendered, you should be able to find the text 0 on the widget. So here you say expect find.text finds one widget. And then you might also want to expect that you are not finding the text 1 or anything else at the beginning. After that, you can start to simulate an action, which is you can run the tester.tab. So here you are finding the add icon on the screen. Then after that, you run a tester.pump. This is to ask Flutter to build the widget again in the test environment, because in the test environment, unlike when you are debugging the app, it will build the app, build the widget again when the state change. But in the test environment, you have to do it manually. So you have to run the pump method. Then after that, you should check that, okay, now you should no longer see the text 0, and now you should see the text 1. So that's what the tests do. Then you might also want to simulate some other events, not only the button tap events. You can also simulate, for example, the scrolling events and the pull to refresh events. So if you want to simulate scrolling, then you can use the tester.fling, and then you put your finder as the viewport. And then you define how much you want to scroll. So I just put the values here, which is the widget height. Then for the widget height, you can find out from the media query command. And then same goes to pull to refresh. This time you can use the tester.drag to simulate the pulling action, and then by how much. So there are some other events that you can simulate also, like for example, if you have the swipe left or swipe right, then you can use tester.drag as well. Or if you have a form, you have text field, then you can use the tester.enter text. Then make sure you find the field here, and then what is the value you want to key in the field. So just now I talked about the tester.pump. So sometimes you will need to run the tester.pump and settle. So if you have a series of events running in the widget, then after you have performed certain actions like tester.tap or tester.drag, then if you are expecting some state changes or some widget changes, then you should run the tester.pump and settle. So when you run this, it will pump a few frames until it no longer have any frames that is scheduled after that. So I mostly use this. Sometimes I would use the tester.pump, and then you can also put in your duration. So just now I have shown that how can you run your unit test and widget test in Visual Studio Code. You can also run in the command. So you can run Flutter test. Let's see. Yeah. So when I run Flutter test in my terminal, then it will run all the tests that it can find. So what you can do is for all the tests, it should end with test.dart. So it can do all the magic here. Or if you're like me, you are using Visual Studio Code, you can also click on Run just right above of your test definition. Or if you want to run the whole the test that is inside the file, you can also click on this one. Then you can see the result at the panel here. And then finally, we have integration tests. So what is an integration test? Integration test is an end-to-end test. It has a complete app or a large part of the app. And the goal is to verify that everything that is contained in the app, including all the widgets and your services, including your backend, work together as expected. And then some might also use this to verify your app's performance. So integration test, because it's end-to-end, it can do everything that widget test and unit test can do. And actually it runs on a real device or an OS simulator. So and because it runs very slow, so they are isolated from unit tests and widget tests. So when you run the Flutter test command just now, it doesn't actually run the integration test, even though you have already included in your project. So this is an example of an integration test. So first, you will need to import and use the Flutter driver. And then you need to connect to the Flutter driver in your setup. And then after your tests have completed, then you should close the driver. Then you will continue to write your tests here. So it's the code is a bit similar, except that it uses the driver to get the finder, and then it checks that okay, the counter should start at 0. Then when you tap on the button, then it should increment by 1. So you should be be able to find one in my counter text now. So how do you run the integration test? The command is different. So this time you need to run Flutter drive and then define your target. So let's see like what test you should write. Just now I've talked about the unit test, widget test, and integration test. So it actually depends. Each test has its own purpose. So like just now I mentioned that integration tests can do everything that widget test and unit test can do. So it gives you the highest confidence because it tests everything in one package. But the maintenance cost is also the highest. So you can see that, okay, this one has very, it provides lower confidence compared to widget tests and integration tests. But the good thing is it also has fewer dependencies and the execution speed is very quick. That means as you are developing your code, as you are changing it, you can run unit tests and widget tests rather quickly instead of you have to wait for the integration test to finish running first before you can continue to make the changes. So you can see that you should give yourself, you should write a good balance of these three different types of tests. And then how much tests you should write, actually, it depends on your code coverage. So code coverage is a measure of how much code is executed during testing. And notice that this is different from test coverage, which is a measure of how much test cases is executed. So if you haven't heard of code coverage, it is actually important to ensure that your code is thoroughly tested and it would fail, that it would not fail on the edge cases. So for example, if you have code coverage of 50%, but then you see the all tests is passed, how much confidence do you have for your code? It's actually quite low because your test, it only covers 50% of your code. So it depends on which number is better for you and your team. Some team would say that, okay, maybe 70% is good enough. Some, they say, okay, must have 90% or a perfect 100%. So yeah, it depends on your team. So how to check your code coverage? I can show you in the code again here. So I can run Flutter test -- coverage. So this will not only run all the tests, but it will also generate a coverage file called the lcov.info. So this is the file it has generated, but then it is not very readable. So what we can do is we can use the gen HTML command to help us to generate a report from here. So what I can do is I use the gen HTML command and then I define the output folder, and then this is the input file. So I have actually run this command before, so I will not run it again. The output is here. So you can see a bunch of HTML files, which you can open with your browser. Then you can see, okay, my coverage of this project is 83% overall. And then you can see the line coverage in each file. So you see the this file has the lowest coverage. So if you click inside, you can see, okay, these are the missing lines from your test, because the test that you write, it did not cover these lines. So you should probably write more tests to improve your test coverage, code coverage, sorry. So my presentation is about to end. So where do you go from here after you have learned an introduction to what is testing all about, what are the types of tests, then you can check out the Flutter testing codebooks. There are many examples inside. And I find this how to do unit testing in Flutter post in by field stacks is quite useful for me. So you can check out this website also. Yeah, that's all for the presentation. Thank you very much.
How do you know what would be the maintenance cost on the slide? Which test that they should do?
Uh, for unit test is the lowest because when you have written a small function and the cost is low is because you are unlikely to make changes to all the smaller functions. But if you are writing widget tests, it is higher because in one widget, you might call several smaller functions, or it might contain some child widgets. So when your widget has changes, then you probably have to make changes to your widget test as well. And then for integration test is the highest because let's say when you have some feature changes, then you have to make make a lot of changes to the integration test that you have written. So that's what I meant by the maintenance cost.